The first thing, we know there are other so-called oxygen products out there, the cell foods, the different things. What is truly unique about our O2 drops?
Well, that's a great question to start with, Shelley, and I thought perhaps the best way to do it is also to try to tie in some history. Oxygen as a dietary supplement, and that's really what we're talking about here, has been available for more than 30 years and in various forms and formats. In therapeutic work, if you really go back 30, 40 years or so, these supplemental approaches to health involved an attempt to try to stabilize oxygen atoms in some way, some shape, or some form in a liquid medium, and to try to get them in a way that they could be consumed or ingested. The very first forms of really oxygen supplementation used ozone, or they tried to use dissolved oxygen as a gas. And when we talk about diatomic oxygen or oxygen as a gas that we breathe, that's really O2, or two atoms of oxygen joined together electrically. Unfortunately, these molecules of oxygen in the old days, again using ozone or dissolved oxygen as a gas, they could not remain dissolved in the oxygen or in the solution, and they quickly dissipated. And that happens usually in a matter of minutes, sometimes in a matter of seconds. So they had to find another way to do this. So the next approach was to try to use hydrogen peroxide. Now, we're not talking about the hydrogen peroxide that you can find, under the kitchen counter or in the bathroom counter that's actually about 3% oxygen. You really need to use food grade, which is something that can be consumed. Now, unfortunately, food grade hydrogen peroxide has a very, very low pH. We'll talk about that in just a tiny bit. But that pH usually is about 1 or 2, which makes it very acidic, which means in its concentrated form, hydrogen peroxide as a food-grade form can actually burn the skin. It can burn the esophagus. It can burn the membranes in the mouth. So, it really wasn't very practical. On top of that, hydrogen peroxide, when you put it in water, breaks down into singlet oxygen, which is O1, and a water molecule. And that singlet oxygen atom tries to combine with other oxygen atoms that are in the water or anything that's organic in the water, and really doesn't last any more than 5, 10, 15 minutes, and then it's gone. So that, as a form of oxygen supplementation, really didn't last and really wasn't very practical either, especially from a safety standpoint. Hydrogen peroxide can explode, it's flammable, and again, it's extremely caustic. So the route let's try to find another oxygen solution. And so oxychlorine compounds were formed, and they're really just using a chlorine atom attached to a salt molecule, forming chlorine dioxide or sodium chloride. And probably 90% of the oxygen supplements that are available today on the internet are chlorine-bound oxygen salts. They're highly caustic. They have extremely high pH. Again, we'll talk about that in a second. They're very, very caustic to the skin, and you've got to dilute them in order to use them. Now, oxychlorine compounds, as again, sodium chloride or chlorine dioxide, are used as a bleaching agent, and you can find them in the wastewater treatment industry. You can find them in bleaching pulp for paper. You can find them also used as a bleaching agent for flour. They're used as tanning agents. So they're great from the standpoint of high tanning compounds, and they're very stable. But there is no scientific evidence whatsoever that a halogen-based oxychlorine compound or chloride-based compound oxygen supplement can actually do anything for the body. Excuse me. So that's really important to know that what else is out there isn't stable or is stable and is highly caustic and really has no scientific basis that it actually can improve the oxygenation of the human body. So finally we come to the one that we're using for O2 drops, and it's called polyatomic tetraoxygen. And that's just a fancy scientific way of explaining that there are 4 individual atoms of oxygen that are bound together to form O4. It's extremely stable. It's twice the atomic weight of O2, which means it stays in solution. It's extremely stable in distilled water for long periods of time, and we'll talk about that in just a few minutes. The molecules are easily absorbed into the body. It's extremely easy to get them into the bloodstream. They break down immediately once they do get into the body into 2 molecules of diatomic oxygen. Again, that's 2 molecules of O2 that gets directly, again, into the bloodstream, picked up by the hemoglobin that are on the red blood cells and taken out to the trillions of cells that are in the body that absolutely need oxygen second by second of every day, of every month, of every year that we're alive. So that's really the bottom line of what's in the O2 drops. Well, what makes it even more unique is that we add a very proprietary blend of plant-derived minerals to that O4 mixture. And those minerals that we add are actually there to help promote energy production. And we call those minerals lyophilic third state minerals. And we're going to talk about that in just a few minutes because I know that's one of the questions that you have. So in a nutshell, that's what really makes this formula different than anything else that's available on the market today, why it's so safe, so easy to use, and so beneficial to the human body.